Hi everyone, welcome to another video. Today I'll show you how to build neural network models in R. Given the limited functionality of Rattle in terms of building neural network models and linear regression models, for this week's exercise, we are going to directly type commands into our R console. Now, if you're not familiar with R, that's completely fine. You can simply go through the exercise and you will see that some of the commands or some of the codes that are used, they're fairly straightforward. And obviously, if you have any questions, you can always bring them to your next lab, or you can post them in the discussion forum. So in order to build neural network models, the first thing that you need is you need to install the package or the package neural network. And to do that, you simply type install packages neural net, and it may take a few seconds. And once it's downloaded, you simply call the package by typing library neural net. Now, the next thing that you need is you need to access the data. So the data set that we are using for this week is the weather data set. Now, remember, the weather data set is another inbuilt data set that we've worked on in previous weeks. So to get to that data set, you need to set your working directory onto the file that the CSV file is located. So the Rattle data set, it's one of those Rattle data sets. So to do that, you simply set the working directory as the path that is mentioned in the lab sheet. Now, if you've located or if you've downloaded Rattle in your local machine, then you need to make sure that you get the correct path. And it's case sensitive as well. So make sure that you type the letters as they appear in your file in your local folder. So now that the working directory is set, we simply call the data set, and we call that weather, and we read the data set, which is the weather data set. And if you call the weather data set by just typing weather, you will see that you've got the data loaded into your R console. And it's got a bunch of variables. It's got a few variables, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 or 13 different variables. Now, what we want to do is, in terms of building a neural network, we want to look at a subset of data. In this case, we want to look at the wind speed at 9 a.m., the humidity at 9 a.m., the pressure at 9 a.m., and cloud at 9 a.m., as well as temperature at 9 a.m. to be able to predict the temperature at 3 p.m. We are going to talk about what neural network actually does, obviously in the lecture and also in the lab. But for the purposes of this video, we just use this data set, or a subset of the data set within the weather data set. So again, it's case sensitive, so make sure that you type the letters as they appear in your sheet. Humidity 9 a.m. Then pressure 9 a.m. Cloud 9 a.m. and temperature 9 a.m. and finally temperature 3 p.m. So now we've selected a subset of our data. Now, if you want to look at your data, you simply call it, and you will see that only six variables have been selected, including the wind speed, the humidity, pressure, cloud, temperature at 9 a.m. and temperature at 3 p.m. Now, once you obviously observe your data, once you investigate your data, you will see that there are some missing values or zero values, as you can see, or the data is not scaled. In other words, some of the variables, for instance, pressure at 9 a.m. is in thousands versus humidity, which is in, for for example, 60s or 80 or 82 or 62 degrees. Obviously, what you have to do now is, and we've talked about this in previous weeks, you have to transform your data. So the first thing that you have to do is you've got to remove all the missing data, right? And to do that, you're using the NA or is not available function. Essentially what it does is it looks at the data set and it looks at all the missing, all the not available values, and it's going to replace them or remove them. Now, the next thing we have to do is we have to partition the data, and then we need to use the scaling function, which in this case is the minimum and the maximum, to scale the results, and we need to scale them to the attributes between 0 and 1. Now, there are other transformation functions. For example, if you want to sort of scale them between -1 and 1, well, for this exercise, we're just going to use the 0 and 1 intervals. So we are going to partition the data first. And to do that, we first have to index our data. So we are going to look at 75% of the data. Again, don't worry too much about the command. If you read through the data, if you read through the command, it actually kind of makes sense. So essentially for the first one, as an example, we are only going to look at 75% of our data in the data set that we've or the subset of the data set that we've just created. So 0.75 times the rows in the data that we've selected. And we are going to look at the 75%. We are going to say this is our training data, and the remainder is going to be our test data. So the trained data will be data and the index that we just created. And the test will be the data that we have minus the index. So that 25%, 100% minus 75 is 25%. And that will be our test data. The next thing, and I've already talked about this, is the scaling. Now, don't worry too much about the syntax. I'm simply going to copy and paste. And if you're going through the exercises yourself, again, feel free to sort of copy and paste from the lab sheet, but make sure that you understand what you're doing. And we'll talk about this in the lab anyway. Now that we've also scaled the data, we just simply create the train based on the index data or the scaled data. So again, train, just make sure that you're gonna use a different name. Otherwise, if you use the same train, it will not provide. I mean, when you're calling the train data, it will be the R console is going to obviously give you either the error as to, okay, which train data you're referring to. Is it the data without transformation, or is it the data with transformation? So make sure that you're going to choose a different name: train 1, train 2, train X, whatever you want to call it. It has to have a different name. And we're going to look at the scale data index, and we do exactly the same for test data. And minus index. Now the pre-processing is complete. We are ready to train our first neural network based on the attributes that we have to predict the temperature at 3 p.m. Okay, so again, I'm just going to copy and paste into my R console. And I'm going to look at my neural network. And now my model is trained. So essentially what it does is it's looking at these variables: wind speed at 9 a.m., humidity at 9 a.m., pressure at 9 a.m., cloud at 9 a.m., and temperature at 9 a.m. to predict temperature at 3 p.m. And in my neural network, I'm using 2 layers, or hidden layers. So the first layer has 5 units, and then the second layer has 3 units. And then the activation function I'm using is logistic or softmax. Again, you can look at other activation functions, but for this exercise, you're going to be using the logistic. Now, if you're familiar with R, you can look at the neural network function by typing help neural network, and you will see that there are multiple other parameters that you can fine tune to be able to potentially get a better or more accurate model. Now, you're simply going to plot our neural network, and you will see that hopefully you're going to get something similar to this. And you've got the parameters, you've got, for example, the error, and you've got the variables 1, 2, 3, 4, 5. So these 5 variables are used as the feature to be able to predict the output, right? This is our target variable, temperature at 3 p.m. We have also 2 hidden layers. So the first layer has 5, and then the second layer has 3 units. Again, we will talk about this in the lab in more detail. Now, to get the actual number, you simply use the compute function. And you're looking at the first to the 5th variable, which is those variables that we've already defined. And you're using the test data. And if you use this again, so we use these two to sort of scale the results, because remember, we use the function min max to scale the results, to normalize the results in ranges 0 to 1, but now we have to rescale them to get the actual values. Because if you look at, for example, the predicted neural network, you will get values between 0 and 1, which is probably not what we were looking for. We were actually looking for the actual values. So if I type PRNN, now you will get, this is what I was talking about, between 0 and 1s. Now, if you look at the test R, now this is the values that we are looking for, okay? Now, if you want to visualize this to give us a better sort of sense of what we've just developed, and that's essentially is what we are looking at. So the predicted versus the actual test data, so real numbers versus predicted for the neural network. Now, this is fairly similar to the linear regression, which is the next sort of bit of exercise, but this is fairly straightforward, so I'm not going to go through this. It's fairly straightforward, and we're just going to use the linear model function to develop a linear regression model. Now, please have a go through this and create and plot the linear regression, and have this somewhere ready, have this model ready somewhere and save it if you want. And once you created the linear regression, then you are able to sort of to compare and contrast the 2 models to see which one is providing you better accuracy. Now, there are other, obviously, exercises, like I said, to do exactly that. And in the end, you're going to get something like this to be able to see which one has a better performance. Now, like I said, I'm not going to go through this. This is fairly straightforward. I just wanted to show you how to build a neural network model using R. Again, if you don't know the code, if you don't know the command, it's no big deal. Essentially, we haven't done much. We've just created the data set. We looked at the subset of the data set. We wanted to see, for example, 5 variables. If you use them as input features, how do we go about, for example, predicting temperature at 3 p.m. As a target variable. Then we looked at scaling and removing missing values, and we also build a neural network model. We trained a neural network model using a partition data that we've gone through. 75% for the training, and then 25% for the testing. So have a look at this, and again, if you have any questions, please feel free to bring them to the to your next lab. This is it from me. Thank you and goodbye for now.